So we've talked about the derivative of sine and cosine, but what about other trig functions? Well, we can use identities to help us out with that. For example, the derivative of tangent x. Well, what about tangent x is just sine x over cosine x. Now, I'm going to use the quotient rule. Low d high minus high d low. Over low squared we go. Over low squared we go. The derivative of sine x is cosine x minus sine x times the derivative of cosine x is negative sine x all over cosine squared x. So you have cosine squared x plus sine squared x, right? Negative times negative all over cosine squared x. And Pythagorean identity, cosine x squared plus sine squared is 1, so that's 1 over cosine squared x. Hey, that's just secant squared x. So the derivative of tangent x is secant squared x. Some other important trig derivatives would be cotangent is negative cosecant squared, secant is secant tangent, and cosecant is negative cosecant cotangent. Let's apply it. The derivative of y equals x minus tan x. So you have y prime would be the derivative of this minus the derivative of this. All right, the derivative of x is 1 minus the derivative of tangent is secant squared x. And you're done. That's it. You may think, hey, that kind of looks like an identity, and I thought the same thing. 1 plus tangent squared x is secant squared x. So if you subtracted secant squared x, you would also have to subtract tangent squared x to get this to that side and this to that side. So you have 1 minus secant squared x is equal to negative tangent squared x. So that would also be an acceptable answer for your derivative, negative tangent squared x. In this one, we're going to need to use the product rule. I'll call x my first function f, and then secant x will be called g. The product rule, f to g plus g df, f to g plus g df, f to g plus g df, f to g plus g df. So we'll take f times the derivative of the g function plus g times the derivative of the f function. And then we will continue to derive. This is y prime. X times the derivative of secant x is secant x tan x. So we'll multiply x by secant x tan x. And then the derivative of x is just 1, so plus secant x times 1, which is just secant x. We'll go ahead and clean it up. X secant x tan x plus secant x. And some answers leave the secant x factored, but either way is acceptable for me. Plus 1. So either of these are acceptable answers. 1 minus cosine x over sine x. So I'm going to use the quotient rule. Sine x times, okay, just to take a look at this over here, the derivative of 1 is 0 minus the derivative of cosine x is negative sine x. So the derivative of this quantity is positive sine x minus The derivative of sine x is cosine x. So 1 minus cosine x times cosine x. And then I will simplify, see if I can combine any like terms. Sine squared x. Okay, I'm going to put this negative in front of that cosine, so, and then distribute the negative cosine. So negative cosine x and positive cosine squared x over sine squared x. Oh, sine squared x plus cosine squared x, that's just 1 Pythagorean identity, so 1 minus cosine x over sine squared x, that is my answer. But if you're anything like me, you're trying to avoid the quotient rule at any time that you can, just because it's kind of a pain. So I noticed that Trig, I actually have identities that I know that help me to manipulate trig expressions. So this function right here, y equals 1 minus cosine x over sine x. I would like to try to rewrite it so that it's not a fraction at all, so I don't have to use the quotient rule. This becomes 1 over sine x minus cosine x over sine x. 1 over sine x is cosecant x, and cosine over sine is cotangent x. This looks like it might be actually a lot easier to derive than the other version that we just did. So let's try it. Y prime. What is the derivative of cosecant x? That is negative cosecant x cotangent x. Negative cosecant x cotangent x minus the derivative of cotangent x, which is negative cosecant squared x. And now we'll simplify. Negative cosecant x cotangent x plus cosecant squared x. Wow, that was a lot less steps than we had to do over here. But the answer that we have does not look exactly the same. So let's check. Can you rewrite this one? Is it equivalent to this one? Okay, are these two answers equivalent? Well, this is just 1 over sine squared x minus cosine x over sine squared x. 1 over sine squared x is cosecant squared x minus, and then you'd have a cosine x over a sine x, and then you still have a sine x on the bottom. All right, that would be cosecant squared x minus cotangent x cosecant x. This is the exact same as the ones we had above. So any of these would be acceptable answers for your trig. Derivative